When the SITRANS LT500 is started, the top-level views are displayed. There are multiple views shown which can be configured for the format and data that are shown. In order to configure the top-level views, navigate to the Setup menu by pressing the right arrow and then down into Setup and then to Local Display. Here you can see that the brightness, contrast, and damping, as well as all the different view types, are available for editing. Let's take a look at our first view, which originally showed 3 values in a horizontal bar graph. We can change the format of this view by looking at the list which is included here in the Display menu. If we simply wanted one large value so that we could see it from a far distance, we could select that and then select which value we want to display. Level, space, distance, volume. Again, the options for point 1 and point 2 are all available. Let's select distance just to notice a change of what we have done as we came into the LT500. You can left back arrow through the menu and to the top level view again, and now we can see that distance for point 1 is our first view. All of the different views have these options, and you can see that we can scroll through the views by using the up and down arrows. Some views have additional details which can be accessed again by hitting the right button for further information. This allows the LT500 to be very flexible as far as the user needs for what they want to see on the display and how they want the information displayed. In order to quickly set up a SITRANS LT500, press the right arrow key to enter the menu. Select Quick Start and Quick Commissioning. This provides a step-by-step procedure for setting up your application. First, we will configure measurement point 1, and we will make it a level application. Enter the units required, in this case we will use meters, and a SITRANS LR120 radar transmitter. The lower calibration point is set as 6 meters, and this is the distance from the sensor to the bottom of the tank. The upper calibration point is set at 1 meter, and we will change this to be 0 meters from the sensor to the top of where we will be measuring material. We go to the next screen and we select the response rate, material type, and then on to the next selection. We apply our changes to see them on the run screen. Now let's set up our second application. Again, we go into Quick Start and Quick Commissioning and measurement point 2. This time we're going to do a volume application. We still need to set our length units and our volume units and move on to the next section. This time let's choose a SITRANS LR110. Again, we have to enter our lower calibration point, our upper calibration point, the response rate, which I will change to medium in this case, the material type, which we will make a liquid, and then what vessel shape. For this particular application, let's say it's a half sphere type vessel. The A dimension is 3 meters, and the maximum volume is 900 meters cubed. We then apply our changes to set our volume application. When we return to the top level view, you can see that the level information is still being displayed. We can easily change this in the Setup menu under Display to show our volume information which we are interested in. For our final setup, we will look at a volume flow application. Again, we select our length units, our volume flow units, which device we're going to be measuring with. In this case, we'll select the SITRANS Probe LU240, the lower calibration and upper calibration point, For a LU240, we will change this to 0.2 meters. What response rate we would like. The material type is obviously liquid for a flow application. And which type of PMD we have. The method of flow calculation must also be selected. And then we enter our PMD dimensions. For this application, let's say we have a 0.5 meter wide approach width. Our throat width is slightly smaller. Small height, and a relatively small length. The maximum head, zero head offset, and low flow cutoff can also be set before we apply our changes for our volume flow application. The fixed duty assist routine mainly uses one pump to control the liquid level. In this example, pump 1 will always start before pump 2. When the liquid level reaches the pump 1 on set point, pump 1 will turn on. If the liquid level continues to rise while pump 1 is running, pump 2 will start. Pump 2 will assist pump 1 to lower the liquid level. Both pumps will turn off when the liquid level reaches the off set point. This pump sequence is fixed. Pump 1 will always start first, then, if necessary, pump 2 will assist pump 1. In the alternate duty assist application, as the liquid level rises, it turns on pump 1, and if it continues to rise, pump 2 will assist. These pumps switch as the liquid level lowers to the offset point, and now it is pump 2 that is the primary pump, and pump 1 will assist if the level continues to go above. The pumps continue to rotate back and forth to ensure that the load is shared between them. The service ratio duty assist application uses a pump ratio to define which pump will turn on and which will assist. In this application, we have a 1-to-1 ratio, so both of the pumps will run for the same amount of time. If we were to use a 2-to-1 service ratio, pump 1 would run twice as long as pump 2 at any given time during a pumping cycle. This would be a good application example where we have one pump with a high capacity and one with a lower one, and we'd want to make sure that we use our larger capacity more than the smaller. We will start with pump run-on. Pump run-on is a feature in the LT500 which helps clean out the pump after the level has reached the offset point. Wall cling reduction introduces a variance into the level on and offset points. This helps ensure that buildup does not occur on the inside wall of the vessel in the same spot over and over again. By changing the on and off set points, we ensure that buildup does not occur in the same spot over and over again, creating an obstruction which could be seen as a false reading. We also reduce the maintenance on the inside of the vessel, increasing safety. The inflow or discharge adjustment helps to account for material that is being removed from the vessel while the pumps are running. It helps ensure that it is an accurate pumped total. Delay between starts is used to reduce a power surge from all the pumps starting at the same time. This delay determines when the next pump is permitted to start. The power resumption delay is used to reduce the power surge from multiple instruments starting their pumps immediately on power resumption. When this delay expires, the pumps will start. Pump energy savings are used to maximize the use of pumps during periods of low energy cost and minimize its operation during periods of high cost. Prior to the peak period, the SITRANS LT500 runs the pump to reduce the level of wastewater. When the peak period starts, the SITRANS LT500 switches to a different set of high and low set points. The wet well now stores more wastewater before pumping starts. During this peak tariff period, the pump runtimes will be shorter, and less energy will be consumed. When the peak period ends, the pump set points return to the normal off-peak settings. The SITRANS LT500 can have up to 5 different peak time intervals, so even when the peak chart goes from this to this, the SITRANS LT500 can still save money. Pump interlock is used to ensure that pumps are running when activated and not in a failed state. Interlock can be used to ensure that any pump reporting a failure is removed from the pumping rotation. Now that you have the SITRANS LT500 set up, you can use the simulation function to check to make sure that your configuration has all been done properly. In the Maintenance and Diagnostics menu, you will find the Simulation menu. Here we can see that there are 4 different options under Simulation which we can control. In Process Values, we can simulate either 0.1 or 0.2. We can enable the simulation by choosing a ramp or a fixed value. Ramp will show the difference between the cal low and cal high value, and the simulation value is where the ramp will begin. In our particular example, we have a cal high of 0 and a cal low of 6 meters. So if we start the ramp at 9 meters, that is where our simulation will begin. The rate parameter is whether the simulation moves quickly or slowly. In the Totalizer menu, we can enable each individual totalizer and a totalizer value. Simply enable each totalizer individually and then input which value you would like to see on the totalizer. In the Inputs and Outputs menu, we can simulate what the milliamp output can be for 0.1, 0.2, turning on the digital inputs, and turning on each individual relay. The Diagnostics menu offers a comprehensive list of every diagnostic that is available, whether it's a status signal or an independent diagnostic. Below, the sensor, process values, totalizers, inputs and outputs all list an entire suite of diagnostics which can be turned on or off and set to ensure that you have set up your LT500 properly. Now that we have set up our LT500, let's take a look at what's happening on the run screen during our simulation. We can see that the value is increasing as it is coming up onto where the relays trigger. This ramp will continue up to 6 meters before it stops and then comes back down again. We can see on view 2 that we currently have 5 of our 6 relays running. We can also see that the vertical bar graph is tracking our level and will go from 100 down to 0%. All of our relays are set to turn off in this current setup at 0 meters. Our relays switch off and our simulation continues to ramp back up. We will see our relays turn back on again at 3 meters. I need to continue pressing the left arrow just to make sure that the screensaver doesn't come on. And now all of the rest of our relays have engaged. In order to turn simulation off, we go back into the Maintenance and Diagnostics menu, down to Simulation, into the process value that we were simulating, and we disable it. We can now go back out to the menu to see our actual measurement value. In order to enable viewing an echo profile on the LT500 screen,
We navigate to the Maintenance and Diagnostics menu and go to Diagnostics. Echo profiles are not enabled by default to ensure that they don't disrupt with any communications from a Bluetooth app or from an engineering tool such as Somatic PDM. To enable echo profile viewing, select Enabled, and this allows us to view the echo profile wizard. Once in the echo profile view, you can use the up and down arrows to zoom in on the echo profile. Once zoomed in, you can press the right arrow to change the function to pan, and then you can use the up and down arrows to pan across the profile as well. To exit the pan function, press the right arrow and we return to the zoom factor. Pressing down again returns us to a zoom factor of 0. To exit the echo profile, press the left arrow to return to select which measurement point you would like to look at. In order to activate an auto-false echo suppression, return to the main menu and go to Setup. Select Sensor and then down to Auto-False Echo Suppression. We can see that right now the auto-false echo suppression is disabled. If we enter a range, which we will keep at 6 meters, and perform a learn, the echo profile function will be started. The auto-false echo suppression takes approximately 30 seconds to complete. Now we can see that the auto-false echo suppression has succeeded completely. We can press the right arrow to exit the menu. And now we can return to our run screen.
The SITRANS LT500 features a variety of different alarming and diagnostic options. When we first go into the product at the top level view, we can access the different high and low warning and alarm set points in the Setup menu. Navigate to the process values, and here we can see all the different process values that are available. Within each PV, we can see that there is several different alarms which are enabled by default, above and below limits, as well as warnings and in and out of bounds alarms. Each of these alarms and warnings can then be set based on the individual set point found in the same menu. In order to turn one of these alarms into a relay output, we navigate to the Inputs and Outputs menu and select which relay we want to assign those alarms to. Let's say on relay output 4, we want to have a high alarm. Under Mode, we select Alarms and Diagnostics, and from there, Process Alarms. On level point 1, I can select a high or above alarm limit. Save this setting in order to set the relay. Now we can select a different type of alarm on a different relay. For relay 3, let's input a low alarm. We follow the same procedure, selecting Alarms and Diagnostics and Process Alarms. There I can select a low warning and add it to this relay. In order to add a sensor type diagnostic, we can select another type of relay, Alarms and Diagnostics, and Sensor Diagnostics. Here we could add loss of echo, for example, or several other options which you can see available on the screen. Multiple options can be selected and added to the same relay. However, that is a customer preference, and anything that is selected will generate a relay output. Save your settings. Now we can see at our top level view that these new relay options have been entered and they are now showing on the screen.
Siemens, ingenuity for life.